record. Alright. So, right now we're going to be doing a little review. It's not going to be the entire test. It's strange having only one person here. We only have Christina in attendance today for the review session. So, Christina's asked some questions. We're not going to cover everything that's on the test, but we will cover some topics right here. And we're going to cover the rest of the topics if you need them to be covered on Monday. A great start to review is just to look over your quizzes. I made most of the tests straight from the quizzes. There's a couple of questions that are a little bit different, that are a little bit more difficult, but most of it, I'd say 90% of the test, is based off the quizzes. I just changed the numbers. I'm telling you right now, I just changed the quizzes, and that is the test. So study the quizzes if you did well on them. If you didn't do well on them, find somebody who did do well and look off of theirs and see what they did so you can answer the questions correctly. Okay, so let's get started. The first topic we can talk about is average atomic mass. Okay, so average atomic mass is just describing the various isotopes that are around the world. So let's give you an example. Let's say that, I'm just making this up, let's say that carbon, which is element 6, has a couple isotopes. One isotope is carbon 12, and another isotope would be carbon 14.
This is very small.
You'll be able to see it.
Alright.
The other one's carbon 14. So a question I could ask you, first of all, these are isotopes of each other because this one has a different number of neutrons. A question I could ask you on the test would be something like this, and this is just a basic question. I can ask you more complicated questions than this, but I can ask you a question like, assuming that there is in the world that 99.52% is this kind of isotope, and the rest is this, so I'm just going to leave this as a blank percentage, what is the average mass? Carbon. Okay. So the first thing you do is what would you do?
Find the percent of the isotope. You don't know.
That's right. So what's like this gotta be? It's gotta be
1.1. Yeah. Is it 100 minus?
Yeah, it's 100 minus this.
I mean 10. No, wait, 1.
I'll show you.
What?
It might not even be 1.
Alright, what
yeah.
do you think? This is 99.52%.
Something that
So what's
0
left?
point.
That's right.
I don't know.
You got it. Come on, you got it.
You can do this. It's just a little bit of
Can you? I don't want to do math.
I know it's the end of the day. It's pretty tough. 4, 8. No, you don't think.
Okay.
That's fine. Okay. So let's just use let's use another sig fig. Let's use 3 sig figs for this.
Crazy.
Come on, you got sig figs. Alright, so now to figure out what the average mass of this carbon atom is, all you do is you multiply this percentage in that decimal form by the mass, of course. So this is going to be 12 AMUs, okay, times 0.952 plus, we got this one over here, this is going to be 14 AMUs. Don't let this limit your sig figs.
It was 3 sig figs, right?
Yeah, let's use 3 sig figs. Alright, see you later.
Bye.
See ya.
0.480. Okay, let's do that. And it gives you an answer. Okay? Trust that you can just calculate that out yourselves. It's just going to be this times this plus this times this. And you get an answer. The answer is going to be somewhere in between 12 and 14. It's probably going to be closer to, you can see this 99% of this is
12.
This is going to be closer to 12. Okay, so it's probably going to be 12.0 something. Right. If you get an answer that's like 11 point something, then you know that you're wrong somewhere in this calculation. If you get an answer that's, I don't know, 22, then you know that something is wrong here. So it's a good way to double check your answer to see if it's in between these two numbers. Okay. So let's get the music going. What else? So that takes care of average atomic mass. I could ask you pretty complicated questions that start off with the average mass, and you have to kind of figure out the percentages. That's a weird one. It's kind of a tricky one.
Which one? What do you say?
I'm saying if I give you the average mass, and then you have to work backwards to find these percentages.
But you will give us one at least.
I would give, this is a simple one, this is an easy one. I might give you a tough one.
No, I mean, you will have to give us one of the percents.
Oh, no I don't. I don't have to give you anything. I could say, I'm going to make up a new problem right now. I'm going to say that the average mass, just right now at the top of my head, making it up, the average mass of carbon, average carbon mass is, I don't know, I'm just going to say 12.135
Okay.
AMUs. Okay? And then I'm going to ask you, what percentage is, what percentage abundance, I guess, is that and this? Percentage abundance is this and this. So carbon 12 and carbon 14. Okay, you set that up, it's just like the other way, except you are kind of just given the answer and you're working backwards. So it's going to be 12.135 AMUs. Okay? And you're going to start off with 12 AMUs over here. And it's going to, I'm just going to say that this is X.
Oh,
Right?
I remember
That's the
this.
right? And then you're going to add this. I know, this is a long time ago, wasn't it?
X.
14 times 1 minus
Yeah,
X.
yeah.
Right? Well, this is
I remember.
AMUs, of course. And you can solve for X here. And then whatever X is, that's going to be the percentage for 12 AMUs. So it's going to be for that isotope. And then whatever 1 minus X is, that's going to be the percentage for the C14. Okay? So that's that. That's the harder version of an average atomic mass problem. Okay?
You got it.
Alright, so let's go on to fission and fusion. How's the battery doing on there? Does it have a battery?
It's red, but it's still even.
Okay, so we gotta get going if it's red. Okay. So fission, fusion. Fission, fusion is pretty easy. The main idea of fission is that you're dividing things. Fission is division, and fusion is a union of atoms. In fact, the only problem that I ever give you for fusion is when I say hydrogen plus hydrogen equals helium. So that would be something like this. And that gives you something, you have to tell me what that is, plus, I don't know, a neutron. There's a neutron. Okay? So this right here, it's got to be, you can see, it's got to be helium. Right? So to double check yourself, you got to make sure that these two sides over here, 1 plus 1 equals 2 plus 0. And it does. 2, 2. And over here, we've got 5 on the top. We add those two together. We have 5 on the top over there, and we add those two together. So both sides, both levels equal each other, so it's all good.
Can you ask us to like write a single fission reaction,
Yeah.
and then use its products as reaction?
Oh, that's a tough one. No, I won't
Right.
ask you anything like that.
Okay.
That's a little bit, the question's too confusing to ask, so I'm going to ask that on the test. It's going to be very straightforward. You'll know there won't be any kind of mistake. Try to get it so you don't have to ask any questions on the test. So a fission reaction would be something like, I tell you that, I don't know, this element like uranium 238 splits. Say you collide it with a neutron, and it splits. And I can give you the information that it goes into, what's an element that you want to pick? Let's go to element, what's in the periodic table? Let's choose. Do you want to choose one? Just a smaller element than uranium.
Aluminum.
Okay, aluminum. So aluminum. Al. Al. So Al is element number 13. And there is, I'm just going to make this up. I'm making this up. I'm giving this to you right now. I'll just say it's got 32 overall mass. Okay? And I'll also give you the problem, maybe I'll say there's 1 neutron, maybe there's 2 neutrons. But you'll have to figure out, here's a box, you'll have to figure out what goes in the box. What element is missing here to make everything balanced? So this is a fission reaction, but you have to fill in that last box over there. So let's do it. So we've got 92 on this side, and we've got this over here.
So
And
79.
I'll show you an easy way. I've never gone over this in class for you guys yet, but I'll go through an easy way. Let's do the bottom first. So it's going to be 92 plus 0 equals 13 plus 0 plus 0 plus x. I'm just going to say this is x for now. And it's really simple. You just solve for x. I know it seems really easy right now because there's so many zeros, but when you get to longer problems, it gets a little bit more complicated.
79.
So this turns out to be, wait, let me do this real quick. 92 equals 13 plus x. So this is going to be minus 13 on both sides, right? So this turns out to be what?
79.
70 what?
9.
79. Alright? Yeah, that's right. So this has got to be element number 79, which is which element in the periodic table? It's element number AU.
Gold. Ooh.
Gold! It's solid gold. There we go, AU. Now,
Oh,
let's do the top.
that's wrong.
Pretty cool, huh? It's a nice element to get. So let's do the top. So we've got 238 plus 1. And that equals, we've got 32 right here, plus 1 plus x. So now the algebra step kind of makes a little bit more sense. So now we can keep track of all the ones up there. So in this case, it's going to be 239 equals 34 plus x. I just added those ones in there.
205.
So minus this, it's going to be 205. X. Good. So now this is 205, and that's the right answer. Okay?
Yes.
So simple.
Will you do like one that you have to write like a number between before the neutron? Like 3?
Oh, maybe I could do that. I could say how many neutrons, if I give you this,
But you
and then you
want...
say how many neutrons we have.
Oh.
And then you say,
But
oh,
you
there's
won't
2.
do both, right? You won't do like...
No.
Okay.
There's only one thing that you have to fill in there.
Okay. I think you have to write a little lower.
Okay.
So this like goes better.
Alright, sounds good. Now you asked about wavelength.
Yeah.
You don't need to know that red is 650 nanometers.
Okay.
You don't need to know that. You don't need to know that purple is around 400 nanometers. You don't need to know that. You do need to know that violet, or purple, has higher frequency and a shorter wavelength, and higher energy. So I'll write that up really quickly. So purple, or violet, highest energy, shortest wavelength, and what else? What else we going to say? And fastest frequency. Fastest frequency. Okay. Now, we have a couple equations that I'm going to give you on the test. I see the sheet open. So here's the equations. We've got, this equation is going to be given to you on the test. So it's E equals hc over lambda. Okay. This constant is going to be given to you. Given. This constant is going to be given to you. You'll be, during the problems, you'll be given either this or this, and you can find the other one.